GIS and remote sensing datasets. So, okay, so this is HKH region. I think in the first presentation yesterday, Basant has on this. So we work for 8 different countries from Afghanistan, Myanmar to others. So we mainly work in the mountain areas of the HKH region. So this is our area of work. And this is a global asset for food, energy, water, and everything. So this is also known as a third pole because of the ice and snow repository on this area. So we work on these high mountain areas. So with this, all the glaciers and snows, it brings the big rivers on this region. So they have 10 major Asian river systems, which supports 200 million people on their life and livelihoods. Okay, there. So this is a basic brief about the ISI mode. So I don't want to talk more. So what we are facing on ISI mode, mostly on the disaster side, is facing like a flood. Like a flood is quite a prominent factor here. Like in Kathmandu also, last time we had a flood. Uh, so in the Belamchi River, which killed a lot of peoples and destroyed a lot of properties. So flood is a natural phenomenon here, like for Nepal, Bangladesh, Bhutan, and if you name it, there are more countries there which is in the flood, maybe India too. Yeah. So these are crises. The second one is also a drought. Drought is also a major issue here, like if you consider in Pakistan and Afghanistan. So the drought conditions are sometimes becomes worse. Like last year, there was drought in Afghanistan, which our system also demonstrated there. So according to IPCC, also we are considered as a drought risk area. The whole issue is. And thirdly, I have also something like a wildfires or the forest fire. So this is one of the applications which we have developed, taking the data from the NASA. So this shows the severity of the fire in Nepal. And also last year we had a very bad air quality due to these fires. So these are a few of the disasters, but we have more kind of things. So if you see this report, which is published by ISIMOD, the distribution of disaster in SKS countries, so we see the kind of disaster we have and how much damage it makes to our people around the SKS region. So this is a report which is published by ISIMOD, the Hindu-Kush Himalayan assessment. So this report has, I've taken this image from this report. So this is a severity of the damage what we have. But why we are having testing? So that is, if that is a question, then we would like to answer that in this part of the region, like the mountain areas of HKH, there is a big data gap, or there is a lack of data, let's say, not a continuous data set, not there. And if you see on the river network or this kind of things, we only have in situ stations, which doesn't provide a long enough lead time for the flood or other disasters to come. And also the limited information content. Like if we have information also, it is quite limited. And the capacity vary according to the region. Means some regional member countries are highly advanced, like if you go to India and China, they are quite advanced. Or some other countries, like if you consider Nepal, even Bhutan, or sometimes even Bangladesh, we are low on the capacity of detecting these things. So these kind of things are there. And there is no end-to-end information system in all these countries. Okay, and last one is there is no opportunity for cooperation within the transboundary issues, like the data sharing issues are there. So these are some of the factors like why the disaster occurs and why and it damages a lot of people's livelihoods, life and livelihoods in the region. So in order to fulfill, ISMOD has implemented the Earth observation systems. Like ISMOD doesn't have a lot of data on the ground-based data, but we are quite rich in the observation data sets. Like we are using a lot of models, a lot of data sets, and a lot of collaboration between the different organizations and the university and preparing these data sets. Okay? So we have one of the program or initiative called Survey, which is doing this kind of things. So the main motto of this survey is connecting space to the village. Like all the information generated or created by the space that should be easily transmitted to the villages. And we are here at Piximode. So we are also one of the member of Survey. So we are also getting these kind of data set, and we show you how to disseminate this. So regional model, we have quite some, but on this presentation, within the time limit of 1 hour, I will briefly describe some of the models what we are using. So three of them. One is ECMWF Grow Fast Stream Flow Prediction Tool. In a later on, I also have a demo of this one. So this is one of the models. Second one is a high impact weather assessment toolkit for the smaller region like Nepal, Bangladesh, Bhutan, and some part of India and China. So this is also there. And third model, which I'll be talking about, is a SLS model, like South Asia Land Data Estimation System. So this system is mainly used for drought and drought forecasting systems. So we are a system. I'll be talking on this one. So first of all, let's come to the South Asian Land Data Assimilation System. So this is a co-developed with the Johns Hopkins University in the US. So we are working together with the Johns Hopkins and ISIMOD, and we have developed this model. So this gives us, okay, let me go to one. So this is a GDAS-based modeling system. Okay, it has a data of 5 kilometers, and we have historical data from 2001 to the latest, because we run this every month, so we have a latest data set of this one. So this model is run with a list software framework within ISIMOD. So we run this model every month and generate the forecast and the now past data set on the drought parameters. So this is one of the model. So here the model takes the parameters like landscape information, meteorological data sets to the system, and plus, sorry, I clicked the wrong one. Then also the observe station. So it takes all of these things and generates the hydrological outputs, which is then outputted to our system, which we do a visualization of. The second system is ECMWF flood prediction system. So this is also jointly developed by ISIMOD and BYU. It's called Brigham Young University of the US, and with also support from the NASA there. So this is something like it's based on the ECMWF Grow Fast. ECMWF is a European center which generates a forecast in a grid format. So on top of that, with the voltage table of the rivers or a river network, we put the rapid process and generate a drainage network with the stream flow, like the volume or the stream flow prediction. We generate it. Then after that, the data is generated. We have the historical, we have return periods, we have a forecast. This gives you a 10 days forecast for the stream flow with the major streams and a river network. Then we have different applications which has been demanded by our partners or the users. So we create them and we disseminate. So this is actually, this model runs year round. So the model is always there, and it has up to 15-day forecast, 10 to 15 days. It gives a river flow, and the forecast type is a probabilistic forecast. Okay, this runs every day, and the model system is ECMWF dataset with a rapid model. And this generates the 52 ensemble models, like the 51 ensemble model, which it generates is 16 kilometer in resolution, and the last one, which is 51 is 1, and 52 one, the last one is 8 kilometer. Okay, so we have two kind of forecast, and also we have ERA interim data set, that is a historical data set, which is of 40 kilometers. Am I audible now? I don't know.
Yes, you are audible.
Okay, it was so quiet, but I got confused. Okay, okay, thank you. So last of all, I will talk about high water flood prediction system. Okay, this is again a joint development with ISIMOD and NASA. This is one of the best kind of system what we have till now, and this is mainly used in the flash flood forecasting system ISIMOD, though it has the and the extreme weather type, like it can also forecast the hailstorm, lightnings, okay, the flood forecast and other damage. So this is quite a popular forecast during the monsoon time, and lot of the government agencies within the center, like from Nepal, DHM, and from Bangladesh, FFWC, they are also using this tool within the monsoon time. And this thing is run on the US servers. So this model is only available within the monsoon period, that is from the March to the September. So this runs only on the monsoon period. So the input data set for this one is the WRF data sets with other data set like a GFS and ENCEP. So after that, it is a UEMS model, and there are also the 12 ensemble outputs from this model generated. And this 12 ensemble model has been joined to make a one probabilistic forecast. Okay. So if we talk about the resolution, so this is quite a good resolution. It's a 4 kilometer resolution for Nepal, Bangladesh, and Bhutan. Plus, if you go for higher one, is 12 kilometer resolution. This is the two domains on which the model is run. Okay. So it is a 54-hour forecast and majorly used for flash floods, and it only runs in the season, like only in the monsoon season it runs. And these are the different uh, ensembles it engine generates output for. And these are some computer hardware resources which is used to run the model. And if you see, these are the output from the different ensembles. So we have 12 ensembles on the dataset part, but when we do a visualization, we do the a single combine into the single probabilistic based forecast and do a visualization of the outputs. So this is HiWatt Extreme Climate Portal, which I'll be showing in a little while as a demo. And this is a HiWatt flash flood for the river network. Okay, so it has a colored codes showing the return period. It has a forecast there and a historical data set. So this has been used by DHM Nepal, NCHM Bhutan, FFWC Bangladesh, and also the local NGOs within Nepal like Pani, Mercy Crops, and a practical action. So we are quite a useful kind of a model is there. So this has a color code for all the rivers with the probability risk there, and also there is the river names and these kind of things. So these are the three models, which I'll also have a demo of it. So we also have on the data distribution side, we have API access on this kind of data. Like if the other organization want to access our data set, the live data set, then they can connect us with the API system. Okay, so we have a separate page for API where the different partners can connect and access the data set. And on this website, we have also mentioned how to connect to our server and so on. Next thing is that quite the thing is a data validation part. So since we have a lot of this flood on the HiWatt side, so we did some validation with Bangladesh portion FFWC with their station data set. So what we found out is that, so we have a hydrostat tool which is developed in a Python system. So it is quite flexible in calculating the parameters there and it also can use the historical and the forecast data sets. Okay, so this tool is there. So we did a joint forecast with the FFWC where we use their station data set and we compared that with our historical model outputs. So what we can do is that we can compare these two data sets in the chart, like observe and this thing, and we can also fix the times and other things within the validation tool. Okay. So this is also a web-based tool, but this is not the public because this is only access to the concerned partners who want to do a validation for us. So here you can give your data sets. So this tool has a plotting of your from your observed stations. So it also shows you the gaps where the data is missing, and sorry, this is the observed data set and also the values on the chart. So on this particular example, we are showing a discharge from maybe 1992 to 2020, so somewhere in between. Now we can overlap this with the observed with a simulated models. Like this one is simulated model, and the green one is a observed, and the blue one is a simulated output from the model. So when we see this, so except these few outliers, the model output somewhat try to match the observed data sets. Okay, there's a gap, so we didn't use this gap. So there is some matching error, but there are also some like outliers or the wrong or over prediction is there also there at some point. But most of the time, it try to similarly match with the observed data sets. Okay, so this is also the scatter plot here, which further explains the output and with the best fit. Okay, so with this software, we can also calculate the mean error. So there are a lot of tools, so also a lot of algorithms on error metrics. So we have to use few of them to validate. So we see get this kind of result on the comparison. So what we find out from this validation is that our data doesn't match with the observed data from value to value. Like we are quite different on the value to value based comparison, but we are quite, most of the time we are accurate when we do the occurrence. Like if our model says that the river is showing risk, then it happens, the river flow in the natural case becomes higher, but the value might not match, but the river rises on our forecast. So that we see from a validation. So we did validation on these points, like we did validation on these 6 or 7 points of the Bangladesh area, and we found that and a few points on the pond. So we found that we can also only do a categorical forecast only with this our model output. Like if we cannot compare value to value. That means if you say that discharge will be 10 uh, cubic meter, then the same is not on the discharge. But if we say the discharge will be higher, then of course the discharge is high there. So what we can see from it on the categorical forecast is that if our forecast is yes, there is a flood, and the observation also said yes, then it's a hit, means we are accurate here. If our forecast is yes, the observation is no, that is a false alarm. Our forecast says no, the observation says said yes, that we missed the forecast. And of course, if no one knowing there, then we also correctly negative. So that's how we did the validation. And the conclusion, okay, I just drop there because I'll be showing a demo more on the demo portion. Like success stories on this, our forecast has been quite a significant in last couple of years. So there were a big flood in the Tharding area where our one of the participation of our trainer, they forecasted, they look at our system and they say that there will be forecast there. So he also warned the people of that area, and of course then the flood came on the time where we have forecasted, and it could save the life and livelihood of the people. So this also came in a paper. So that is a school teacher who has been one of the training participant, has used our system and was able to save some life and livelihoods kind of thing there. And second, this one is of course the endorsement by the government. So they are also using our forecast maps or data to use as one of the input parameters on their national level forecasting. This is also there the other parameters, but within the other parameters, our system also has a role there. The third one is that this is also taken by our local NGOs. Like I said, we have also the API system on the data sets. So this API system has been used by one of the government enabled NGO called people. So they are using our data sets to show the stream flow predictions within their portal is there. And also we have a practice action. So in order to do this forecast kind of thing, we have used a platform called a Tetis platform. So this is a very high-end platform, which is based on the Python, the open source platform. So why we use open source is that a lot of time looking at our application and their usefulness, the partners comes to us to have the application replicated on their system. So once this kind of request comes, then we are quite flexible with open source to replicate this kind of things. Okay. And last two of my slides are a bit on the data download part, which is there. So whatever data we are showing there, this is very much downloadable from the other website called a thread. Sorry, go back. Called a thread server. So if time permits, then I will also show you how to download these data sets. So is there from a thread server. And thread server is mainly used to download the time series dataset. Like if you have a real-time dataset which is going for a long time, then you can use a thread server. Plus, we also have other system called RDS. This is called a regional database system. So if you ask me the policy of EC mode, then EC mode has a policy that whatever data EC mode generates, it should be in the public domain. Like whatever data set we develop during the various projects, so that should come in a public domain, and everyone should be able to access that data set for their own uses. So with that policy in line, so we have put all our data sets on the regional database system. So with a minor registration, one can download the data set from this site too. So then I will go for a few demos here. So maybe before going to demo, do you have any questions on my presentation? Or if not, then I can go for demos. Can you put in chat?
उनको अब अंदर आप भी को बताऊंगा जल्दी अंदर आओ आप ही बुला रही हैं अभी बुला रहे हैं
So I see then I don't see anything on the chat. Maybe I'm not seeing, or Raishi, can you see it on the chat? Any questions are there?
In the region. So
there is no question right now.
Started some investigation.
Okay.
So
was that a question, please?
There is no question in the class.
Okay.
Dr.
Okay.
Dinesh
Okay. Then
has already.
Please go ahead.
Yeah.
Okay.
Currently,
Then let's go to the demonstration of my page.
The chipset can support.
Can you see the website which I am demonstrating, Raishi?
Yes, Kenji.
Yeah. So the first demonstration for me is the HiWatt application. So this, which I've also shown in a PowerPoint, this is 4 kilometer data sets. This gives you a 54-hour forecast for the various parameters. Like we have a lot of parameters here. We can have a rainfall, like a precipitations, lightnings, wind speeds, and a hailstorm kind of thing. So these are the parameters there. So the user can have a 54-hour forecast. See, like first of all, I have both for 1 kilometer accumulation precipitation in there. So this is my model. Let me clear this out. And this is a forecast. Like you can run an animation here. So it will show you the precipitation forecast for 54 hours. So this is an UTC time zone. So you can see how the precipitation has been forecasted by our model. And these are digits. Okay. Similarly, you can also, and by the way, these all the website links which I'm showing you is on a public domain, and you can also browse this website at your own convenient time. Okay, this is the forecast, and if you want to see the statistic of the certain area, then you can draw the polygon of your interest, and it will give you. I don't. This is my last one, so it is refreshing. So it will give you the precipitation forecast on the form of a graph. Like this time, maybe the precipitation is a bit higher, okay, and this goes down like this. This is for precipitation or the rainfall. Next, you can also do for other things like a lightning probability. So if there is any probability of lightning, so I clear this one I don't think there is lighting probability in this area. So this is, so at initial time the data loading might be a bit slower depending on your internet speed, but it shows the lighting probability. As I predicted, there is quite a less. Okay. Okay, let me not spend much time here. So let me see if the hailstorm prediction is there or anything. I don't think so also, but let's see. Whether hailstorm or prediction for the hailstorm is also very less, because though it's showing the some graph there, but it is very less, because if you look at the region, the probability is very less. It's coming here. So it is 100% should be a rate or something like that. So this is one of the tools which you can use to see the 54-hour forecast within this. Wow, what happened to my browser? I think something got refreshed. Okay. So this is one of the application called a HiWatt. And second application I'm going to show you is about the same thing, HiWatt, but same thing. Now we have used this rainfall precipitation to model in our stream flow forecast. Okay, so this is a HiWatt stream flow forecast. It gives you a 54 hours forecast as same as the previous model, but this is mainly useful while you are going to predict the flash floods, because the input parameter for this HiWatt stream flow prediction is only and only rainfall. So this input parameter is only rainfall. So this is mostly used for the flash flood only, not for a normal flood. So we have a separate application for that. This is a flash flood, and this coloring like a red, orange, yellow, and blue are showing the return period kind of things. So what kind of risks are there? So this is there. Now, if I click on the certain place, like this yellow ones, it shows me the chart. Okay, so this is a forecast, so that the rainfall is predicted very high in this one area, one time, and it goes down slowly. So this is there, the forecast for this thing. And of course, if you want to see the forecast of the same river segment on the past days, like for 11th, you can do the same. So this is the forecast for the same river segment for the segment 11, that is July 11th. Similarly, you can go back till the 7 days back or 1 week back and see the forecast prediction. Okay, for the same river segment. Of course, you can also see the historical. So I said that we have data from 1980 to 2015, more data we are processing. But you can also download the historical data sets for the particular river. And this last button is a download. Like if you want to download the forecast, which I have shown, or the historical, then you can go there and download the data set for your further uses. Okay. Of course, this tool has different layers also, like this outline. You can also search by districts. Like we have district search. You can also put the river names. Okay, but not all the rivers have names. But we try to put the names wherever possible, and you can also search by the river name. So if you selected the topmost person, will come there. And on the last this monsoon time, what we have figured out is that there is no search by the area of the river name. It's quite confusing. So we have added one more function which is already there on the open source platform. So this is by a search. Okay, search. This will use the API from the OpenStreetMap. This is a geocode search. So if you want to search and see if you know the river's name of Nepal, then BAGMA, Bagmati River. Okay, so people may not know where this Bagmati River lies. Okay, so if you can do this, Bagmati, I think I spelled right or wrong. BAGMA Bagmati. Then it makes a search there, and then it gives all the possible points. If I see the Bagmati Pradesh something, that it will try to show where that particular area or particular thing is. So I have to say something different. But similarly, you can also see the Bagmati is a big river. It flows from the big up to low, so it's giving the area segment of Bagmati. Like there was a flood in Melamchi, M-E-L-A-M-C-H-I, Melamchi thing. So looking at this map, you don't know where the Melamchi lies. That's it. So you can make a search here. Melamchi, try to focus this area. Okay? And the flood has happened. I think if I'm not wrong, let me put the river names. So, river names. So this is a Melamchi Khola, and this is upper like Kholas. Khola, yeah. I think the flood has happened somewhere in this area where the two rivers upstream on this area. So this makes your searching capability quite easier with the OpenStreetMap geocoding tool. So you can easily spot your areas and do the further analysis on these things. Okay. And a third is I'm going to show you about the same stream flow, but this is called ECMWF stream flow. And this stream flow is jointly developed with ECMOD and DEYU, like a university, and this is a ECMWF forecast. And this data is available globally, but we have refined it for our basins of the ECMOD boundaries. Like we have a Amodarya Basin, Brahmaputra Basin, Ganges, and Indus. So you can turn on and off as per your requirement, okay, or whatever. And of course, this is a 10 days forecast system. It has a similar coloring code, like from 100 years to 2 years to time period. And it also shows the severity of the river discharge according to the color. So if I click on somewhere here, this takes a little bit bigger time because the data set is quite a big on this one. So because it covers a big area. It's taking longer than I expected, but it also depends upon the heated bandwidth. Okay, so this is showing me the forecast historical flow duration and download. And I said this ECMWF dataset has 52 ensemble members. Okay, so this chart is showing the mean of the all mean, max, and everything of the all the ensemble members. And but here there is also the percentage of probability calculating all these ensemble. Like if some ensemble says that the flood is high, but maybe other ensemble model might say that the flood may not have happened. So this particular date, so the percentage of a 2 years flood here on a 7-12 is 100%. Means most of the models say that 2 years return period might come there. This 2 year is not that much risky one. It's a light blue, so it is 2 years. But is there chances of having this ENS return period? According to the 52 ensemble, only the 76% says okay that the 76% probability is there for 7-12, means July 12, the 10% on the 13 and so on, and the 53% on the 7-16, like July 16. So this kind of a 10-year return period might come, this kind of things. Similarly, for the 20 years return period, means the discharge will be more. So what is the probability or what is the percentage? Means on 7-12 is just 65. On this period is 0-0, so there will not be big flood on these areas. But here also the probability is quite less. So if you study this, if there is some expert on this kind of thing, so they might think that okay, on the 7-12 there might be some kind of a high discharge on the river, but others I think though it is showing some colors, but the probability here is quite less. Like for the 20 years it is just 16%, 35%, 10%. This is quite less. So you don't have to worry when you see the red colors. No, because red color is only shows if one of the probability shows more than high. But once you examine that table, I think I shouldn't have closed that one, but then it shows that it is not that much severe. So you must also match with the river colors and the tables how being generated. I did a mistake. I shouldn't have closed that one because now it's taking a long time to load because I have to show something more there. Just a minute. So this is taking a little bit more time because it runs for the whole HKH region. This is there. Of course, similarly, we have the historical data set. This one has a longer historical data set from 1980 to 2020. Of course, you can download these things also. And it also have a flow duration chart. Okay? And also similarly, it has a download. So you can download either forecast and the historical data set. But please note that when you download the data set, then the time period will be on the UTC format because this is a regional database and we cannot put any national time kind of thing, like for the Nepal time or Bangladesh time or Pakistan time. So this is on the UTC time. So if you want to use this data set, please be sure that this is on the UTC time zone. And if you want to compare with your ground data set, then please change the time zone to according to your requirement. So if you don't change it, then you might see the errors or a lot of difference in the compact. So this is what we have on stream flow predictions using ECMWF. This is mainly for the normal flood forecasting. And the other one which I have to is called I don't know what also the flood indentation map. This is a newly developed application, and we are also what do you call it, updating on this one. So this is a flood indentation. So it also gives a live near real-time data sets. So the range is from 516 to 730. We have a data set till 730. Means today's data set is also there. So this is the flood extension or the flood inundation area which we have calculated from our model. So this one is a perennial river, and this one is a expected flood on the region. Like if you click on the Bangladesh, okay, India portion, and Nepal, but this model is still under development. As you see, there's a flood risk in the upper area, so we have to filter out a little bit. But I just was browsing it, but this is came there. So this is there. This is not that much because this is still under development. Next, we have is a drought system. Okay, so I saw that there we have three models. One is a ECMWF model, which has a 10 days forecast. One is a high watt model, which has a 54-hour forecast, and this is SLR system, which is used for a drought monitoring system. So this model is run within the ISMO area, and we do model for the whole South Asia, South Asian region. Okay. Now, if you want to see this, we have a data set from how many years? From 2000 to the latest one. Okay. And you can also do animation to see how does the air temperature change within the monthly time period. Because this data set is monthly. So this is there. Okay. And of course, the user can also change to the certain basin, like Gandaki, this particular thing, and also do a calculation on the monthly average of that particular basin. So this is air temperature, monthly air temperature within that area. Okay. So the time is the temperature is in Kelvin. So please careful to change to your local time, like most of the people in this region, like degree Celsius. So you have to do a calculation for that one if you want these data sets. And these are the data sets we have. Of course, you can change to any year, and do our calculations. So these calculations are done on the fly. Like once you make the request, this request comes to the server and it computes the statistic on the fly. Like there is no pre-calculation. So it might take us a certain time to do a calculation also. Maybe if we have a bigger basis, like if you choose amount, the rate is bit bigger, but the calculation might take a little bit longer because there is no pre-calculated things. It does on the fly. So this is a regional drought. But after looking this kind of thing, so we have a lot of demand from the local countries that this should be customized according to their country's need. Okay, so to fulfill that, we also have developed the national level droughts. Like this is a same data set which has been used, but this has been especially designed for Pakistan. So we have a drought for Pakistan, Nepal, Bangladesh, and Bhutan, Afghanistan. Okay, these are there. So these are drought parameters for Pakistan. So since this is for Pakistan, then this is districts of Pakistan, and this is no. I think this is a province of Pakistan, and those are the districts. Okay, if I click here, then these are districts there. Okay, and our drought expert, after a long consultation, they said that we need a data set in the form of a decadal. That means 10 days data sets and a monthly plus 3 monthly kind of data sets. So we have categorized the same data set into these categories. Okay, and there are 4 parameters where the user can choose what parameter they want to see. So for a drought to happen, the major factor, and actually we are talking about agriculture droughts. Sorry, I forgot to mention that. Not other droughts. We are talking about agriculture drought. So for this to happen, the parameters which we have chosen is temperature, rain, soil moisture, ET, NDVI, mean temperature, anomalies, and SPI plus these 2 anomaly calculations. So these are the major, let's say, the major features which will affect the drought, which will create a drought. That's what our drought expert assume, and we have put these parameters here. So here you can see 4 parameters at a time, and you can compare one to another. Okay, so this is a current, means that what is there. So since this is calculated during the monsoon time, it starts from October and it goes on. So I have chosen a rainfall at the first. So this is a rainfall here. I have a rainfall data here. I have accumulated rainfall which adds up, and a long-term average. Means long-term average is calculated from the 2020 to the latest data set, and it generates long-term average. So what the long-term average looks like. So this is a comparison of rainfall. Similarly, this is a comparison of ET, soil moisture, and temperature. Okay, and of course, if you want to change to the different, so if you want to see the SPI, this is a precipitation index. So this will show you the SPI range for selected area. Okay, this is the current one. We also have a seasonal. So seasonal means that if you want to look at a certain crop pattern, like the crop pattern have different sowing years. So you can also select the months on which you want to select. I use 2012. I want to limit my search within the certain month, let's say from January to April, let's say, if that's my choice. I want to see monthly data set, then I choose my parameters accordingly. Whatever you need, you can select these parameters as per your need. Then if I draw this, then only for my selected months this data is drawn. Okay. And good part is that under each chart, you can download this in the form of PNG. Like this chart will come in the form of graphics, or if you want to download the real data set, then you can also download in the form of a CSV or Excel, like Microsoft Excel. So after that, you can do this. And if you want to view the table, okay, and all this function has gone. I think I'll look under it. This is there. Of course, you can also do the full screen and make a capture if you like to, or go back to the normal screen. You can do this to everything. Okay, if you want to make see in the bigger picture, like mostly you want to see in the bigger picture. If I select the range, like if I see this current, sorry, if I go to this and go for 2020, then this whole year range, if I choose my parameters, so this is quite a month. It's a monthly. You can also do a ticket like in 10 days. So this is quite a bit hard to read. In this case, then maybe the full screen might help you a little bit. This can also be on the full screen page. Decadal means 10 days, like for January, D1 means from January 1st to January 10th. And this is 11th to 20 and rest all. After 21, this is rest all. Same thing goes, 10 days. We have tried to make this stuff. Okay, let me put it back. And of course, like the previous one, you can also have the and see the real data set, which is same like our regional application. This is there. And lastly, we have this outlook. So we do a forecasting of these 4 parameters like the air temperature, ET, soil moisture, and rainfall. So we have a 9-month forecast, and we run this on a seasonal. Last time we ran on the May. So next run we will run after the month of July. So this will give you a 9-month forecast anomalies. Okay. So with this 9-month forecast anomalies, you cannot predict the particular things, but you can assume that, okay, what kind of the season is coming next. Like if the rainfall is showing less, then maybe so the prediction of rainfall is less, so there is a possibility of drought or not. Or if the soil moisture is going to fall or rise. So this is a tool for decision makers. Now, this tool doesn't make a decision by itself, but looking at this tool, the decision maker can predict, okay, what kind of month we are expecting for the next 4 or 5 months coming ahead. So this kind of calculations or this kind of decisions can be done from this tool. So this is the drought. Actually, I have only 15 minutes, so I want to go to download section if possible. And this is a land cover. I'll just see this one. So this is a land cover system of Afghanistan. So since we work in 8 countries, so I try to put one example of each country if possible. We have a lot of applications. So this is also a land cover dataset which is generated from a Google Earth Engine and Landsat. That's a dataset. So this is 30 kilometers forecast. Sorry, 30 kilometers land cover. So we have land cover from 2002 to 2018. So this is 18 is at the top. Okay, this is a land cover type is here. And these are the values for each of the provinces. Yeah. And this chart is quite small, so if you put the mouse there, you can see it. But if you want to see within this chart also, we can go for a particular areas like province. If I go for particular province for Afghanistan, then this shows the same chart is changed for a particular province and same values here. And in chart also, if you want to see only the less, I want to see only forest, then you can turn off everything and turn on the forest. So the forest area is quite less. If you want to see the built-up area, then the built-up area is here for the year 2018. Okay. Similarly, you can see a whole, and you can see only the features of your interest, like the marsh-up area to see it. Okay. This tool is there. And second one is comparison. This tool is there, which is quite fancy. So if you want to compare the land cover between 2 years, let's say this year I can choose the land cover of 2014, and this side I can choose the land cover of 2018, and I want to zoom to certain province. I don't know much about Afghanistan, but let's see the Kabul. So you can zoom more. So they are quite synchronized, and you can see in 2014 you can also see the legend here. So this, I don't know what is this one. This is a vineyard or something is much here, but now it has been changed to the built-up areas. So you can do comparison there like this. Okay. So this is quite a handy tool if you want to compare with the 2 different land covers. Like I can change again to 2017 to 18, how the things will look like. So this is a 17, so similar to this is 18. So how the land cover will change. So this is a comparison to, see this some changes are here, these things. So this is some of the observation system which Simone has developed for the partners. Like I said in the previous, we have a lot of data gaps within the institute data sets, but we are trying to build or recover this data gap or narrow down this using satellite or observation data sets. Okay. Now, last thing within the 10 minutes I have, so I will show you this RDS systems. So this RDS system is a regional database system for EC mode, from where the user can download a dataset. Like if I see here Bluff, okay, Bluff. If I make a search, or I do something typing mistake. Okay, sorry, it was taking a bit longer time. It did came. So this RDS system comprises of a metadata, which is an ISO standard. I think if somebody knows it. So this is a description of data, how the data is generated. So there is a description, and if you are interested on this data set download, then you can go to download button. So this will ask you to do a small registration because we also want to keep record who is downloading it. And this is totally free. There is no charge of it. So just to put a record, we need to put this thing. So since I am a member of PCMOR, I don't have to register. I can put my name. And it will take me in. Okay. So this is there. And we also have a citation rule. If you want to use this on your publication, so this is how you can cite our datasets. And of course, then this is for what purpose you are downloading research test or something like that. I'll put you can put the description where you are downloading it. So I'm putting test because I can delete this report later. If I do agree, then the download will come here automatically. So this is quite an easy step. So the download will be here. Here. So this download has a data section where data is there which you have requested. You have a metadata, the brief thing which I have shown in XML formats, and also the same metadata on the PDF is also there. I think. Yeah, one in XML format. So if you want to feed this metadata to your system, to your computer, then you can use XML. So since it is ISO format, ISO standard metadata system, and if your system is also ISO standard, then it can easily take this metadata into your system. And for the normal user, where you want to read only, then there is a PDF version of it. And if you go back one step back, then there is also a data download agreement, which shows that how you can cite out data set, this and that kind of thing. So this is quite a simple download process. Now, if you are not sure what to download, then there is also the data categorization is also there. Like if you want to develop this, what kind of data you want, adaptation and resilience, transboundary landscape, river basin and cryosphere. If you are interested in atmospheric data sets, and this will mainly have the GIS and remote sensing data sets. So you can select this. Survey HKH is our initiative here. If you click on this one, okay, my internet is a bit slow. I know. Good, so you can have this kind of data sets to download. I think the thumbnail should have been shown here, but maybe it's due to my speed, I think. So it is here. So so it is here. There is a metadata and there is download there. So I think that is all I have. I have consumed 1 hour, I think. So thank you.
Kiranji, there are some questions. Shall I read?
Yeah, sure.
Yes.
Thank you.
Can I access data for South Africa? I think that is not possible from this.
No. Maybe because in the previous we said we only work for the HKH region only. Yeah.
And there is another question. Is HiWatt available for Bhutan?
Yes, it is available for Bhutan. I said this one. So if your country is within this boundary, then Bhutan is somewhere here. So it is accessible to Bhutan. Yeah. And we are also developing a separate application of Bhutan. We are collaborating with NCHM, National Hydro. I don't know the full form. So we also had meeting maybe a couple of days back. So they want to have this high-watt system especially developed for Bhutan only. So we are working for that. Yeah, the high-watt system is available for Bhutan.
Okay, thank you. How could we acquire cyclone data? Kindly give demo of it.
Yeah, cyclone data, we don't have something like a cyclone data kind of thing. Like last time we had this Yas cyclone, and if you do this animation kind of thing, no, then I really don't know I have a video or not. Let me see. There is not like a cyclone data set, but you have to explore as a, I don't know, this is a cyclone data. Okay, it went to some other screen.
So maybe not possible for cyclone data from this. So
not a cyclone as such. Yeah. So this is a high-watt animation of the times fit for our forecast. Then this is showing the Yash cyclone and how the precipitation will affect on the different areas. So if you analyze our data set, then you can see the cyclone effects. But there is no data something like a cyclone data set as such. This is a Yash cyclone, and this is showing how much rainfall will it generate in the region. Yeah, this kind of things is there, but not a cyclone as such.
And there is another question that the data set that you have shown today, maybe this is the coverage. Is that possible to get global data, or it is only for Asia?
Most of the data set is only for Asia, or not even Asia, it is South Asia, because ICMOD only works on, I don't know, I have open there or not. Yeah, only for Hindu Kush Himalayan region. Most of the data sets are for this region. We have for this dark one, that's this region we have, because our mandatory of our ICMOD is to work for this region. Yeah, so we have that's it for this region.
And same to the same question, what is the resolution?
I don't know which data set you are mentioning, but resolution
that is the same data that you have shown just before.
Oh, this one is a like if you talk about high watt, it is a 4 kilometer, and if you this is a 4 kilometer data sets, and if you talk about this drought, this is a 5 kilometer data sets, and if you talk about this land cover is a 30 meter. Yeah, it depends upon the data set what you are talking about, because each application the data set is different.
That's great. Is there high watt data for Pakistan?
Currently, I say no, because the 4 kilometer data is not there. But we also have the less 12 kilometer data set, which covers Pakistan to some portion of Pakistan. Okay, but this doesn't have that detailed information as we have in the 4 kilometers. But 4 kilometer data set we have, we have ECMWF forecast for Pakistan. This covers some portion of Pakistan, like mostly the upper portion. This portion, I don't think we have it. So this doesn't have a high, all the parameters which I showed before. This doesn't have a good precipitation, like a precipitation water is there. Okay? But this is 12 kilometers. The previous one is 8 kilometers. Yeah, you can say some portion of Pakistan is there, but not fully covered.
Very good.
And you can download this data set too. Yeah.
Okay, good. I feel so. There is one question. This operation is now currently based in South Asia. Is there any plan to expand this for global extent?
Because as I said previously, this data set is developed for our region. So I don't think we have a plan. Like it depends upon the request ID. But This high watt we cannot expand to the global because this has especially set up with the NASA and this thing. So this is not there. If the NASA want to do it, then it's a different case. But Simon, I don't think we will do a global. But the FFWC portion, no, this river network is developed by FFWC. Sorry, ECWF. So this data set for the stream flow prediction, there is a high chance that there will be a global data set soon. But not for us.
So how can we access to the drought data set, and can we download these parameters that you have shown today?
Yes, we can download. How much time do I have? Let's see.
No, there is actually time is almost finished. So
Yeah.
just few.
Yeah.
Maybe you can just respond. Yes, no,
Yeah,
or
you
something.
can download this. This is a separate website. So whatever data I have shown it is on the state server. Like this is a high watt. This SLDAS is for the drought. So you can go here. There is a monthly, decadal, and quarterly. So what you want, you can get here. These all are in NC format. So you can download the data from this is an NC format. So if you click on a particular NC, and so this is how you can download it. So if you click here, then this will show you the parameters what this file has. So this file has about 45 to 50 parameters on one NC file, and if you click here, then it starts the download process. So it starts downloading the data sets. This is how you can download. I could have shown, but I think if you are interested, then maybe you can write to me. Then I can show you because of a time limit. I can show this in the detail. So next question I see.
So thank you very much. I think we cover up all the questions that I can see in the chat box, and many people are also giving you thanks so much. So this is really good. I'm not sure if anybody wanted to speak up there. So I wanted to move to host.
Thank you.
Thank you. Bye.